Hello 108 students, Mr. McCue here, working on section 10.3 like we've been doing here, and we're now going to tackle page 3 where we're going to finally get down here and do some problems with logarithms. And I start off this section here by again summarizing that if you have log, again I keep recommending you keep saying it over again, log base A result B equals the exponent. You need to transpose from log form to exponential form. That's the key to doing these problems. When you see logs, you need to convert it. So you can look at my diagram here one more time. Log with the base with the result equals the exponent. My first step when I do these is I like to drop the result down and say result equals the base. I drop it over here and then I drop the exponent in. Okay, so let's try a couple problems here. Turn around, we look at example 1a. Here we are, and it starts off saying log base 4 result x equals exponent -2. And I convert it, and I like to start with step 1. I drop down the result. I say x equals, the result equals the base, which is 4 raised to the -2. Okay, now that you have this, you got something to work with, because now 4 raised to the -2, we don't care for negative exponents. We drop it down into the denominator, it's 1 over 4 squared, and bang, you're in there with x equals 1/16. Okay, that one's not too bad. Look at example 1b. Might come around here and look and say, oh, it's log base 1/2 result of the quantity 3x plus 1, notice those big parentheses, equals exponent 2. Okay, always the same process, convert from logs to exponential function. So I like to drop the result down, so I drop that whole parentheses and I say 3x plus 1 equals, I take the base, remember it's down into basement, I like to get that in my head, drop the 1/2 and raise it to the exponent, which is a 2. Okay, now that you've converted from log to exponential form, you can start to deal with what you have. And I see 3x plus 1, I see 1/2 squared. That turns out to be 1/4, remember. Next, can I isolate the 3x term? -1 on both sides. When I do that, I got -1 plus 1/4. You could do that one in your head. That one's not too bad. If you owe somebody $1 and you give them a quarter, you still owe them 75 cents or 3/4. Finding this last step, I'd like to recommend here, it's 3x. You're used to doing the closing move where you divide by 3. I'd like to recommend here, which is still fine, I did the work here, but it creates a complex fraction. You can bypass this step if you realize that you've got a fraction on the right hand side by coming straight down and say, why not just multiply both sides of the equation by 1/3, which is the reciprocal of 3. So 1/3 times 3 would produce equality over here, and I take the 3/4 times that 1/3, and here's where I'm maintaining balance on the equation. And when I do that, I have -3/4 times 1/3, and I get an answer of -1/4. Don't forget 3 in the numerator, 3 in the denominator are equivalent to 1. Okay, so squeeze down here to the bottom of the page, example 1c. I got one more in here. Ooh, this one looks a little tricky. I see log 49, log base 49, the result is the cube root of 7 equals the exponent x. Follow the same mechanics. Drop the result down, which is the cube root of 7, equals the base, which is 49, raised to the exponent, which is x. Okay, now we start off this chapter here dealing with problems where the variable is up in the exponent, and the goal here is to rig the bases so you finally get the same base, and then you're going to set the exponents equal. So to start that process, I see the cube root of 7 and I convert that into 7 raised to the 1/3 power. This goes back to chapter 8 there, but that's allows you, every time you have a cube root, you can put the 1 in here. I remember you do the counterclockwise swing, sorry you can't see my hand doing it, but raises it up to the 1/3. Okay, now that we've got that, I see 49 and I'm like, I got to get the same base. The 7 is my hint. for my clue, and I realize 7 squared is 49, so I replace it there. And I've got parentheses, and I've got my inside exponent and my outside exponent. That triggers in my mind to do the power rule. When I see the parentheses, multiply 2 times x. So I've got that in the exponent, and I now have achieved the same base, which is 7, and I've got 1/3 in the exponent on the left side and 2x on the right side. Set those down and set them equal to each other, and I did the work over here. You bring 1/3 down, the exponent down, equals 2x. Now usually, again, you can see I'm used to the habit of dividing by 2, which is fine. Save yourself some work. Come down and multiply by the reciprocal, which is 1/2. If you do that, if you've got the 2 and you multiply by 1/2, they cancel out, and there's the 1/2 over here, and now you've got left hand side, you got 1/3 times 1/6. Multiply the denominators, and there's your answer at 1/6. Okay, class, we are finished up here with page 3, so we're going to keep cruising, and I'll see you on page 4.